Welcome to the Downtime from WTWH Media with your hosts, Sarah Wynn and Sheri Kasperzak, bringing you everything you need to know from the week in manufacturing.
All right, everyone, welcome back to another episode of the Downtime with Sarah Wynn and
Sheri Kasperzak, and thank you so much for spending your downtime with us. And we're back with a new episode.
Yes, Sheri, we have a lot to cover today. You know, a lot of innovations were on display at Automate last week. We briefly touched on it and we shared what will be coming in the weeks ahead. And this episode specifically, I want to focus on a company. It's called MK North America. They had 3 different material handling solutions on display, including a shuttle system that had integrated robotics with IGUS's RBTX platform. They had a VersaFlex, which is a medium-duty pallet conveyor, and a recirculating pallet system that can work in any application where 2 machines need to be combined. And this one is interesting, and I wanted to highlight the recirculating pallet system. The company says it can be used to slash downtime in your facility.
Not this downtime, though.
Different kind of downtime.
Excellent. Wow, that sounds really cool. So, yeah, I mean, I'm sure you got a lot of great information about that. We'd love to hear more.
Yeah, so I got this. We did this interview, I think it was maybe May 13th. And I came back. I wanted to write it up as quick as I could while it was all still in my head. So the story, by the time this episode publishes for the podcast, the story will be live on packagingoem.com. You can view all 3 of the different shuttle systems. We're also featuring a single video on Packaging OEM's LinkedIn that will include demos from each system: the shuttle system, the VersaFlex conveyor, and the recirculating pallet system.
Very cool. Well, can't wait to see it.
So, yes, Sheri, it was awesome to see in person, and I'm fortunate enough the company let me video the booth, so we have all the demonstrations here for you to see on the downtime. So let's take a listen.
Listen, I can't wait.
Good morning. I'm Scott Blaze with MK North America. I'm our sales manager over here, and I've been with the company for 11 years. I'd like to show you a really cool, simple demo that we have on display over here. This is what we call our shuttle system. This is a truly co-branded part of our booth. We partnered with IGUS and their RBTX platform. Shout out to their team. They do a tremendous job helping everyday individuals and established integration partners alike. This is a really simple pick-and-place operation, moving small boxes and parcels. The beauty of this design is it's showing off 3 different material handling solutions. Generic flat belt conveyor that we call our GUF P2000 into the true shuttle, which is an LZR principal and an internal drive roller. And then the box moves down into a plastic modular belt, what we call our MBFP 2040. The bot shown is an RBTX Rebel bot with a Schmalz end effector that actually recycles air to pick and place and establish the box presence. Really low-cost automation, simplistic, and gets the job done, quite frankly.
Hi, I'm Michael Zampano of MK North America, mechanical project engineer, and this is VersaFlex. I've been with MK here for 7 years. For the last 5, we've had our VersaFlex product line. So VersaFlex is our flexible tabletop chain conveyor system that we offer pallet systems and general conveyance for packaging, small parts, and even finished parts. So here, what we have here shown is our AP10 system, which is our medium-duty pallet handling system for work pieces and different machine cells. And various different parts can be used on this based on different sizes and shapes. So what we have shown here is our stop setup with singulation, as well as our lift and locate for locating for machine operations and other different setups. So, and along with that, our racetrack loop here that shows the variety of different positions you could have of these pallets, as well as different orientations of turns and setups. So, this is a little snapshot of our VersaFlex product line, the different turns you can do, and the various different things. one thing that we pride ourselves in is the design to order based on what the customer needs and everything that we need to do to build out exactly the cell and system that our customers do want to have in their facility.
Hi, I'm Corey Santor with MK North America. I've been with the company 7 years, and I'm the current inside sales manager. Today we're with our recirculating pallet system, the SPU 2040. The unique thing about this is it actually allows the pallets to recirculate on the underside of the conveyor and come back to the operator pick without needing a separate return conveyor for the pallet. This is showing our smallest footprint pallet, but these pallets can get up to 3 feet wide and 1 feet long and up to about 100 pounds per pallet. Really saves a lot of space in your footprint, not needing any type of return track. And it's really through the use of just pneumatic stops and lift and locates.
And I really want to thank the team at MK North America, specifically Scott, Krister, Michael, and Corey for all being a part of the video and for letting me film at their booth and share their story. I can't wait to work with them more in the future.
That sounds great. Yeah, that was a great video. Thank you so much. So, Sarah, you were at Automate, but you weren't the only one from our team who was there. Our boss, as a frequent guest of the show, Stephanie Neal, who is our editorial director and just the best ever, who is on a much needed vacation right now. She was also at Automate, and she swung by Schneider Electric's booth, and they were featuring some really cool new AI Copilot software and technology, as well as generative AI technologies, and from what I understand, that was a really cool demonstration as well. I think you were there too. I think that this industrial Copilot was developed in collab with Microsoft, so we love a collab moment. And the Copilot sort of integrates Microsoft Azure AI Foundry, which helps developers build Gen AI applications. And at that demonstration, from what I understand, at the Schneider Electric booth, it was kind of showcased as a PLC code generator. If you don't know what a PLC is, it's a programmatic logic controller. And engineers can generate the code for, so let's say something like a pumping application. I think that was one of the examples that was used at the booth. So it sounds like this was a really cool technology. I know Gen AI is a huge topic that's coming up in engineering. I've seen a lot of things like agentic AI and Gen AI that are really helping revolutionize. And I know that that word is used a lot in engineering, revolutionize, but it's really reshaping the way that we think about engineering topics. So I think you got a video of it, Sarah. So why don't you intro that for us?
Yeah, so I had the pleasure of tagging along with Stephanie to visit the Schneider Electric booth. We spent quite a bit of time there. It was a pleasure to meet everyone. I can't just single out one person. We met quite a few team members. But for my video specifically, Alan Greitmeyer, who is the manager digital factory at Schneider Electric, he walked us through the Microsoft Copilot with the Gen AI. And a quote that really stood out to me, he said, quote, "This is great for engineers." Wow. Not only can they test code, but the Copilot assists in writing code. So he walked us through that pumping application, how he would create the code. The video shows the different screens the Copilot has to offer. So let's take a look at it.
Sounds great. Can't wait.
So welcome. What I'm going to show you is our new automation expert, software-defined automation platform, which has a Gen AI Copilot, which is a PLC code generator behind. What it does is basically when you put a description in, let's say I want a pumping application with 2 stages, it will generate the code output for you. Okay, it can generate code. You can also test code if you write it yourself as an engineer. You also paste your code in here, and you can verify whether the code is accurate or not. So once you do that and paste it in, it generates the code. This is an example, it's already generated. Then it can go in and it can explain each point, each step in the code, and it can go through a detailed summary They can tell you what the code is about. They can do flow diagrams to explain how the code is put together. They can also give explanation of every line in code to describe what the code is doing at every step. This is great for engineers, whatever demographics it is. They can either learn how to do coding for PLCs, or they can learn how to do code for, let's say, ladder logic that they've used for years. That's an older type of programming language. You can type in the description of the ladder logic and the rungs, and it can generate the structured test code for you. What we can do with this as well is we can actually test it afterwards. So this is an example of it testing the code. You do a test case for both errors as well as the process that you designed with the code. So it can run through a simulation before you ever deploy it in your system. So that's what we do there. We have help. It's connected. The difference between something like this in, let's say, ChatGPT or whatever, is that we have all of the libraries, all Schneider products built into this. It's offline. It's not online, so you have privacy. If you're a developer or an engineering company, you're worried about that. So it's local on the machine, and it can help you generate all the code based on all the products that we have, and it also tests and validates it based on the specific applications that we have for all of our technology.
Wow, that was amazing. Thank you so much for giving us that video. That sounds like such a great demonstration, and I'm really sad I missed it, but thank you so much for bringing it to us.
Yeah, and I want to make sure to highlight that it was introduced at Automate. It was a brand new feature that rolled out at the event. So a lot of innovations were on display. This was one of the newest, and we were very gracious to be a part of it and be able to see it in person and in action. So thank you to Schneider Electric, and thank you to Alan for letting me film his demonstration.
Yeah, thanks so much. And we will link Stephanie's amazing article from that booth visit in our show description and over at our LinkedIn. And here comes my weekly spiel, because you know I have to do that. If you are not following us on LinkedIn, what are you even doing with your life? Please follow us at the Downtime. We are at LinkedIn. We are also over at Instagram. You'll find a lot of fun videos, photos from some of our events that we attend. We have a lot of really fun stuff going on over on our Instagram page. It's at the.downtime. So go check out our Instagram. We are also over at SoundCloud, YouTube, and Spotify. So please go check us out on all the platforms. You can find us. So thank you.
Yeah, and if you feel the urge to send a connection request specifically to myself, Sarah Wynn, or Sheri Kasperzak, send it over and say that you heard us on the Downtime and you want to connect.
Absolutely. We love meeting new people. We are extroverts here at the Downtime, and we love talking to people. So
You think we're extroverts? You think?
a little bit. I don't know. I mean, there's some ambiguity. So
And here's a little fun story for our listeners. Before I met Sheri in person, she warned me. She said, "I'm an extrovert." I said, "Me too."
oh, yeah,
So it
off. There you go. We're off to the races.
that's a good way to say it. Off to the races. Nice.
Exactly.
Completed the Triple Crown.
Yeah, absolutely. So it is getting to be that season. And if you don't know what season I mean, it's graduation season. And we are looking into what our new grads are doing. And, I had the honor of chatting with a recent engineering grad, Emerson Kronsnobel. And she gave me some great advice from her time at university. She's from the University of Florida. She talked a lot about her experience taking engineering classes. One thing that I really took away from her conversation was that I think engineers need to try a lot of different things. If you're thinking about going into a particular discipline in engineering, it might serve you well to take some classes that you might not otherwise take. Something that, maybe you want to go into control engineering, for example. Maybe it would do you some good to take some coding classes, because maybe there are things within that field that, a coding class would help you with. Try to be flexible. Flexibility is really kind of the takeaway that I took from our conversation, and she had a lot of really great insights. So Y'all take a listen to Emerson Kronsnoble's recent graduate, and she had a lot of great things to say. So here she is. Hi there. So, Emerson, could you introduce yourself and tell us a little bit about your background in engineering?
Yeah, sure. My name is Emerson Kronsnoble. I'm a recent graduate from the University of Florida, and I graduated with my Bachelor's of Science in Material Science and Engineering with certificates giving me specialization in polymers and biomaterial sciences.
Fabulous. What kind of drew you to engineering as a degree, as sort of a subject that you're really passionate about?
Yeah, so I would definitely say like as I grew up, I was that like tinkerer for like a buzzword, I guess you could say. As I grew up, like building things, I loved Legos. I loved to like take things apart and put it back together. And my mom at the time, my mom had worked at our local hospital in town, so I got exposure a lot to like that medical side. So personally, like I went into even as early as middle school being like, I want to be a biomedical engineer. Little did I know entirely what that entailed, but both sides just attracted me, like that medical side of like being able to help people and make their lives better, and also like that engineering technical side, since I had been really good at like science and math and stuff like that. And it wasn't until like I came to the University of Florida where you get more of that exposure and like what those classes are like. And I know like classes like organic chemistry and stuff like that's something that I really struggle with. So I decided to take a step into a different engineering major, which is what I graduated with which was material sciences, that gives you like a broader scope in general and still allows me to deal with like that biomedical, like medical industry if I desired so, but also gave me a wider opportunity if I so desired for my future, which was really nice. Yeah, so I just always had that like engineering mindset. A lot of my family members are engineers. Like I have a couple uncles like aerospace, civil. One of my cousins is biomedical. So just being able to like talk to them and like go to their work and like interact with them definitely helped build on like those experiences and stuff and like my desire towards an engineering career.
Fabulous. Um, we are kind of experiencing like a labor shortage when it comes to engineers. From your perspective, why do you think that is? And what do you think that, Generation Z and even Gen Alpha that's coming up, what would you suggest for them if they're kind of like avoidant of engineering or STEM topics? What are some things that you think that the upcoming generation should really think about when it comes to career opportunities in engineering?
Yeah, so I think engineering in general, like I think it can be scary. Not like if you're not immersed in it early or start that like fundamental desire, it's kind of hard to get into it just because of the way that STEM works. It's very fast moving and sometimes even like I feel a little bit behind, but like you can't know everything. And I think that through my learning experiences where it's like understanding that failure helps you get better and stuff like that, and maybe like taking that like extra class that maybe is like, because I know I took like, I think it was computer science and engineering, which was one of my AP courses. And like, I'm not the best coder, but it's a good skill to have and it's helped me develop all my other skills. And so I think that the courses, like, the courses that engineers have, like our readout courses, like our physics courses, I know a lot of people, especially at the University of Florida, we take up to physics 2 with calculus, and some students will even take them not even at UF and at other schools, and we'll have to retake courses like that. I know for biomedical, you have to take organic slash biochem, which is a really hard course because they're taking two courses and you mash it into one semester. So I think it's very much like also compiled with that those hard beat up courses that obviously like not everyone can be an engineer, but having to find your group. And I think that being able to have some knowledge, some foundation of like being able to work in that collaborative space that I think engineers work in a lot is really important, because I know that I built my like not just my friend group but like my entire cohort through all of college was very strong. We always helped each other out. So that was really, I think, essential in my like path through engineering, because having those people, not only your teachers and stuff support you, but also your classmates and the people that you work with, I think is not only good to help you um, get through that engineering course, but also to teach you those collaboration skills, those communication skills, those skills that not necessarily every engineer has or has a lot of, I think. And I think that that can also be not only essential, but make you like special in a sense. And like, because I don't think every engineer knows how to like talk to the general public about what they're talking about and stuff like that. So I think just bringing engineering into a light where it seems not only more desirable but more attainable, that like anybody can do this. Like engineering is fun. It's you're trying to problem solve, you're trying to figure stuff out, and that satisfaction that you get from problem solving and stuff like that. Because there's a lot of ways to achieve that satisfaction, whatever job you do, whether it be STEM or not. But I think that that satisfaction is a lot less emphasized because of either maybe like the burden or the struggle that they think engineers might face.
Right. Just from your experience at the university level, what sort of hands-on experience did you kind of take away from that where you were kind of able to apply like some of the formulas and theories that you were learning to kind of more real world, like on the job, kind of like I guess examples? Is there like a particular hands-on like experiment that you had that really kind of speaks to you?
Yeah, so actually, one of my teachers at my university level, she is very hands-on focused, having us apply things. She was my lab teacher for a year and a half, and we not only used a bunch of like specialized testing methods and stuff like that, but she helped us really break down like the standards and the stuff that we use as engineers, which helped me carry on through my multiple internships that I had, where sometimes you're just kind of thrown in and being like, okay, like you need to understand this, but you're gonna get smart first by reading these like standards and stuff. And so that was really helpful for me to be able to like break down the ASTM and iOS standards before I was able to even touch the machinery to be able to do my analysis. So that was really helpful. And just having that hands-on like connection, I think, also brings that desire. Because like a lot of people can think like I know like computer science is a lot of like sitting at a computer and stuff like that, but it's like not everyone understands that like you can be using all these different testing methods and what's really out there to learn and how these things apply, which is really nice.
Tell me a little bit about like how you envision the ways in which engineers learn and like function at the university level. How do you see that changing in the next 10 years or so?
Yeah, so I think that there is the way that I feel like engineering is taught at university level. I think it's very structured on us learning those basics, those equations, those the theory behind what we're doing, which I think is um, really important as like our building blocks. But I think classes like I talked about, like my lab and stuff like that, having those more hands-on would help us going into like our technical into industry because you can memorize a textbook, but whether you're processing that or actually understanding that, I think um is harder to actually see if that has occurred, especially with our changing world, with the presence of AI, with the presence of so many things that like impede learning or encourage people to not actually grasp the content they're being taught. But I think by having those technical hands-on interactions where they're actually applying these concepts and not just learning these building blocks is going to help students transform what they know into something real and something um maybe tactile or whatever. But I think that'll also help not only like improve improve interest in STEM because then you have something, it's not just like a concept that you have attained. Like I know like since I have like, oh yeah, like I graduated from university, that's great, but like also like having the diploma is like it makes it feel so much more real, I think. And just having that to show where it's not just like a concept or a belief or something, it's something that you actually know and you can put to work and stuff like that. And I think that a lot of that is happening right now. I worked with some like this year I've worked with some camps with kids actually where we were taking these concepts and giving them actual like microcontrollers or like some sort of like tactile thing to like show what they're doing. And I think not only that helps like the processing of how they're understanding it, so they're seeing it in real life, but also engaging those interests and stuff like that. So I think moving towards that is definitely what's going to happen.
Absolutely. What advice would you give to someone in, say, high school now who is looking to pursue an engineering career?
Yeah, so if I were talking to someone from high school, I would definitely say if they haven't already chosen their courses, definitely take that robotics class, whatever class. I think as definitely as a woman in STEM, I took a couple courses that were engineering adjacent through my high school career. And I think it just really helped me get knowledge and background, but also like I was definitely the minority in those classes, but it helped me learn and collaborate with others that maybe I hadn't in the past and stuff like that. So if they have that opportunity, definitely take that. And if not, just definitely keep an open mind, go into those general courses for engineers. I know at the University of Florida, we have a course called Introduction to Engineering, and they have all of like representatives from every single like sect of engineering come and talk to them and just to explore because I think that a lot of people get like either overwhelmed in their freshman year or just like get that tunnel vision where they want to stick with one thing. But like you don't need to stick with that one specific engineering. There's so many different types of engineering that can cater to whatever your interests are or stuff like that. So I think just really keeping it or open and exploring those freshman and sophomore years, because I know that a lot of kids now do AP courses, like community college courses and stuff, and that's great. And you clap a lot of those early classes, but I think still keeping an open mind because I know a lot of people are here to like get through university as fast as they can. They have all of those credits coming in, and it's something where I think university is very special. It's a special time where you're on your own for your first time, maybe, and this is where you really get to explore what you want to do for the rest of your life.
Yeah, so Emerson had a lot of great things to say. I really enjoyed that interview. So thanks again, Emerson.
Yeah, and I appreciate you sharing that. It is graduation season, SZN season. Lots of new grads coming into the workplace in all fields, especially in engineering and manufacturing. So I appreciate you sharing that conversation, Sheri. And I look forward to talking to any recent grads, or anyone entering the workforce that would be interested in speaking with us on the downtime.
Absolutely. We love new grads. I think higher education is something that we really, talk a lot about here at the Downtime and all of our publications here at WTWH. One thing that I don't think gets talked about enough, and I think I mentioned this in our last conversation, is apprenticeships. And we're talking like continuing education type courses. A lot of companies are looking to upskill their current employees, people who have been in the industry for many years. With things like artificial intelligence kind of taking over in a lot of jobs, learning about automation and how AI works, I think is really crucial. There are a lot of programs out there that will take existing employees and put them through an apprenticeship program to help them upskill and learn new things. And I think they're really great. Watch this space. There's going to be a lot of conversation around this coming up. I'm scheduling a lot of interviews with some organizations that are running these apprenticeship programs. So we'll have that coming up. But also, I think that trade schools can really teach folks who are planning on going into manufacturing and the more modern manufacturing, landscape. I had a conversation, and we've run it here before, but I think it's really worth picking up again from Aaron Prather about trade schools and how it would be really great to get more resources for trade schools, because I think that, in place of things like university education, trade schools can teach you a lot about more practical hands-on labor. So why don't we have a listen to a quick clip from that interview? I think it's really insightful. Do you think that there's real value? And I've seen it, at least anecdotally, a push towards trade school. I think, as the Wall Street Journal article mentioned, there are more careers that are very well-paying, careers that don't require a college degree, that don't require advanced education. It's
Yep.
just a matter of training. Do you feel like we're going to have a sort of revitalization of trade school and maybe even in high schools, a push towards more trades-based education?
Yeah, I mean, I really think the German model, as it's always referred to, I mean, NIST has sent teachers and their own folks over to Germany to look at that model. I was in Stuttgart just last month, and it was interesting because I was going to a conference, and I had to ride the tram. Each morning, I'm riding the tram with a bunch of kids because they're not going to their local schools; they're going to their specialty school. They're going to their university-bound school or their trade school. And there is something to be said about that model because we do know that kids start forming an opinion of where they see themselves going by about the middle school, freshman year ages. So it's like, why don't we get them in those programs? My one concern is I think, and it's still being sort of studied out. I am of the personal opinion that No Child Left Behind really destroyed the trades because everything got pushed to focusing on take the test. We got to show that you're reading and writing and all that, and math is all good. And that huge focus on testing sort of just made all the other stuff fall away. And now it's like we need those skills. We need those trade skills back. So I personally really see a value in trade schools, but now it's like how we have to rebuild them practically in so many places. Now, there are still some great ones out there that are really thriving, and I think that makes the case we need more of them. I know a local high school here just opened up a CNC machine shop and all that, and it's being praised. Like, thank you for doing this. We need this. And it's like, yeah, we need about a dozen more too, just in my local area to keep up. So there is something to be said about it, but I think also it's going to take a big push at the local, state, and federal levels, and I just don't know if we're there right now.
Yeah. Once again, that was Aaron Prather. He is the director of robotics at ASTM International. And as always, we're super thankful for his contribution and that interview. So thanks again, Aaron.
I really loved listening to your conversation with Aaron, Sheri. While you were gone in Vegas, I had to find a way to connect to you in some capacity. So I listened to the Aaron conversation, and it's worth a listen. The trade schools are discussed. The way the curriculum in the United States is discussed. It's very insightful.
I agree. I love that interview. So thanks.
Mm-hmm.
So, Sarah, what is coming up at Packaging OEM?
We have a lot set to publish within the next few days. By this time this episode airs, these stories will be live. You can read them. We have Rockwell Automation's new cybersecurity service that can help protect machines and detect threats from in your facility from a faraway platform, with Rockwell assisting. We also have B&R Industrial Automation's AI machine tending service. So this is another AI. We talked a lot about AI in this episode that can be used to, make sure that you're getting the most out of your machines. So we have everything of that is at packagingoem.com. And in addition, we already discussed MK North America, but that story will also be published within the week. And by the time this episode airs next Thursday, the MK story will only be live for a few hours, so you'll be one of the first to see it.
So, Sarah, tell me a little bit more about B&R Industrial Automation. AI-powered machine health monitoring. Tell me a little bit more about that, because that's something I find really fascinating, especially when it comes to things like predictive maintenance. I think that, you don't want to avoid this downtime, but you do want to avoid downtime with your equipment. So tell me a little bit about how that AI-powered machine health monitoring works.
Well, I'll just say this, Sheri, I'm not going to give it all away. You got to read the story at packagingoem.com. But I will tell you, they have two new industrial Internet of Things, or IoT, apps that enable AI to optimize packaging machine health while enhancing efficiency and performance. So the first app is the IoT connector. And the second app uses AI algorithms to process data from B&R systems so it can help operators react to maintenance in early stages. So Oh, that's a little high level tease for you. You'll
Indeed.
you'll have to review the whole story on packagingoem.com. But it is a neat comparison. When you think about fitness tracking, like for a human, you think maybe a Fitbit or something with your iPhone. You're tracking your steps, you're tracking the calories that you intake to optimize your performance. It's very similar with this, but in terms of machines. So we're using AI, BRs2 industrial apps to monitor maintenance, usage, efficiency. Really, it's a digital transformation tool. Yes.
Love that. Yeah, fantastic. Thank you so much. And yes, go read Packaging OEM's article on B&R Industrial Automation's AI-powered machine health monitoring. So thank you, Sarah.
Yes, thank you, Sheri.
I think that about wraps up another episode of the Downtime. So thank you all so much for spending your downtime with us, and we will catch you on the next one.
Signing off from the Downtime, Sarah Wynn and
Sheri Kasperzak. Bye, y'all.
Peace.